or welcome everyone into this panel session between or amongst the three um, kind of approaches that we have here. One approach is more or less using Grasshopper and developing tools relative to bespoke approaches. Another is almost productizing the process within the firm. And we have Sandeep on the other end, who's developed a product to kind of reach many people, given the size of how buildings contribute to climate issues. So to start on a lighter note, I would like to know from each panelist. We throw around this term computational design, but what is computation in design to you? Anybody can kick this off.
Yeah, sure. I can take a hack at it first. Um, I mean, I think it's very simple. I consider computational design to be data-driven design because at the end of the day, we're using computation to gather more data to become more informed designers. So, for example, to bring it back to the perspective that I share for cove.tool, um, having data about the shadows, having data about views, having data about how many people I can fit in a space, having data about embodied carbon, carbon energy, really anything, all of those are critical for me to know how to design a building. I mean, I could still design a building. I did prior to becoming an expert in building performance and sharing that with the rest of, well, everybody. Um, so yeah, I mean, I think it's the same as data-driven design.
For me, the computational design is really like any methods borrowing methods primarily from computer science or even data, and whether it's a geometry or data, anything outside of the conventional architectural practice, the manual process. We borrow this we take this the computational the methods from other areas for our design practice. So that's how I define computational design.
Yeah, and I would mirror a lot of that. I think coming from the computer science perspective, when I came, I started in architecture and I came back because we never really leave architecture. I mean, I think of it as computational complexity and software coding paradigms like object-oriented programming. And when I came back to architecture, I saw a lot of like visual scripting using Grasshopper, and very much like you said, is like it's using those paradigms conceptually to start unraveling a lot of parts of design. When we look across design process, we're seeing patterns that are repeated over and over again. And over time, we can pull those patterns out and abstract them and create generalized tools to solve them. And for me, in a very simplistic way, that's like casting a global variable in a code. And just these global variables are now view analysis, daylight analysis, things that we can run because we have the computational efficiency to run them faster, more now than ever.
That's thank you very much for that feedback. um I think I'll go to Brandon. um you KPF seems to be developing this robust tools that are addressing policy making, essentially like you said, just being able to even formulate the right question. um would you say your audience is really those policymakers like government? And why haven't you seem to have developed this product. Why haven't you made it something on the market? What's the business um, logic that's guiding how your team develops a product internally?
Sure. No, that's a great question. So I think I'll answer that in a couple ways. So what we've seen, especially on like communicating for policy evaluation or evaluating regulations when we're going for community engagement, people are becoming much more attuned to using interactive visualization. So the audience is there ready to interpret that information, because they're being constantly seeing this information through a web interface. Now, on the idea of us creating this product that we've typically deployed in-house, that is a very great question, because we're currently trying to figure out, we're not trying to solve the industry's issues, while there's many of them within the AEC industry. We're tackling problems that are coming up on design projects. And over time, we've pulled out tools. And just recently, we pulled out enough tools where we can actually create a workflow that we can deploy in the office. And I would say that we're in the early phases of seeing, oh, like this tool can be used for much more, has so many different uses when you're evaluating design performance. Now, the other component of that is that evaluating design performance isn't always necessarily objective as much as my engineering brain wants it to be. Designers are prone to evaluating designs based on their own intuition and experiences. And so I think within what I've seen within the field is that we're starting just now to develop a language to evaluate geometry and designs and architecture. And again, like, I think we're in the phase of developing that language to evaluate. And in the future, we're going to be able to quantify a lot more of those pieces to evaluate properly. The things that we can't necessarily quantify yet.
Yeah. That's a good segue for Sandeep. So he's talking about quantifying, design. How do you see? Is it really possible? Because I think we're getting into this paradigm of, Dongyeop also mentioned the idea of one-on-one with clients to one-to-many, and definitely what you're trying to do is reach many. With the complexity on projects, is it really possible to capture all of that in one product? I mean, I know it's focused on, mostly like sustainability, but how do you capture like all of that and apply it?
Yeah, for sure. Kind of the way that I think about it is the very fact that this is a very, very unsaturated industry. There is so many low-hanging fruits. There's just so much that we need to do to even get started. That it is possible to pull everything together in a workflow that works for everybody. Yes, every design does need an energy model. Yes, every single design does need daylight view model. Yes, there's a way to do it. Sure, some designs might be so unique that it is not possible to model it in an kind of the more automated workflow that cove.tool offers, and that's okay. But the real question is, how many? Is that 1%? That 3% of all buildings? That 5%? Even if it's 10%, that's perfectly fine. I think we need to start by solving the 90-10 problem, which is how we operate at cove.tool. Let's solve 90% of the problem. And then the 10%, the really, really unique workflows. It's okay, we'll get to it. But we got to start somewhere. And I have seen it be possible. Like right now on our platform of 15,000 plus projects that are currently being designed on it, it's every single type of project. It's everything from single family to multifamily, labs, hospitals, health, hospitality, multifamily, retail. Everything that you can imagine is getting designed on the same platform. There are single person teams that are just now hearing about building performance for the first time that use the platform, and 1,000-person teams that have been exploring it, figuring out a way to even standardize it across their different studios, where somebody's a Rhino grasshopper junkie, another person's more a SketchUp person, another person's more the Revit person, to make sure that they're all able to collaborate on the same workflow. So I definitely not only believe that it's possible, I've seen it be possible to be utilized in a very wide range of use cases, just because the market is so unsaturated. Maybe in 3 years, we'll need to really tune in the dials to make everything come together for the last 5%.
Well said. Dongip, amazing to see your like the clustering and using user objects in Grasshopper, and then now kind of migrating some of those to C sharp. Who is your target audience? Is it the designer who's non-technical, not technical in the sense of computation, or computational designers? within your firm? And
Yeah.
if something breaks, for instance, like who reaches out to who?
Yeah. So initially, I mean, it's both to computational designers and project team members. So I also benefit from that. And when the programmers, I mean, I'm not a programmer expert, but you create the functions to utilize that function multiple times later, right? And you call that function to create something else. And this is the same concept like when you do visual scripting. I find many things are kind of the repeating in my scripts. And I also figure out something. I spend like several hours to figure out something, and then later I forget. So it's good to the package them and then save it to our library, and then we can use that tool. You can use that part for later. I often compare these clusters to my tools in my toolbox at home. For plumbing, I don't to fix my home. I don't use a plumbing tool often, but when it's needed, it's really needed. I have to go to Home Depot to buy something, but if I know this is there, I can use it when it's needed. So it's a way to expedite the process of scripting, but also the any project team members that they want to start scripting from scratch, they also can benefit from this. So I'm using this to support project teams and also for ourselves to expedite the scripting process.
So with this is a general question. I'd like to get your take on it. So don't get mentioning, so packaging your scripts, now you're dealing with C sharp. This is beyond
Mm,
visual programming. This is dealing with hardcore code, right?
right.
Um, how would you say that the idea of a computational designer
Mhm.
is only going to change over the years, in that firms will need software development, and the idea of computational designer is something that's temporary? What's your take on that?
Yeah, I think it's a part of the evolving process. Myself, when I was in college, we didn't learn anything about computational design. There was no word about it, and we drafted, by hands, and but now I started using grasshopper, and now the ultimate goal in our practice is the maximum flexibility, the maximum freedom to design something. All right. The very reason I started using grasshopper was I felt that I was restricted by software. I wanted to break that barrier and to get the maximum flexibility in designing something. We use a grasshopper, but then I also feel limited by I wanted to more freedom to do something, and I realized using Rhino Common gives me more freedom to do something that I want. Um, and also, if we want to scale up the use of the tools that we are developing, we need better user the graphic interface, and the Rhino Common would be a better way to do these things on cloud, and scale up the use of expand the use of the computation. So I think it's just all the part of the process, and I don't think this is a temporary thing. I think it's our role is the computational designer is really trying to hack something that are limited by these boundaries the set up by other architects they created these tools. And I think the action of we are doing might change, but the exact meaning of the role we are taking may stay, I think.
Brandon, any thoughts on that?
Sure. Yeah, I think one thing that came to my mind was when I came here from New Mexico, mostly a very small city in New Mexico, to New York, and I started going to architecty meetups. before COVID. And I kept seeing the same people over and over again. Me in my mindset thing, I was like, I'm going to New York. This community must be gigantic who's doing this kind of computational technology area within architecture. And I realized, yes, that community is there, but it's really small. And like as Sandeep pointed to, is that this skill set is just now emerging within our industry, and software engineers even are starting to look at architectural industry. Oh wait, like y'all haven't been disrupted since and you can argue if Revit was even a disruption, it was just doing what we already did. So like this industry is like, it feels like a powder keg in a sense. Like there is so much, there's so many problems that can be solved by software engineering, and just removing some of those tasks that can be that are not necessarily needed within the architectural practice. And I point this to my presentation, is that coming on, seeing that the environmental specialists at KPF were having to deal with like reporting or seeing if someone ran the script properly. It's like, oh, we can totally automate that process. So you can actually talk about like embodied carbon, life cycle assessment. And so you can start talking, having those better conversations with the design teams. And I think that the opportunity for designers to start learning, just understand like coding concepts, it makes you think about your designs differently. And it's not to mean that like every designer, I think, has to be like a coding wizard. Although maybe that will change in 5 to 10 years, depending on where the field goes, as in, is it going to be one tool that solves all of our problems? I'm not sure. Or the interfaces are so intuitive that you don't need coding at all. But I do think there is a massive potential for architects and spatial thinkers particularly to leverage code throughout their design process. So as you're figuring out, do I learn JavaScript? Do I learn Python? Do I learn C#? My suggestion would be like, learn one of them. Python is like the wild west compared to C#, where they're like Python has no rules. And then C# for the most part, you have to deal with classes and whatnot. But I guess my point being is that like, I would start somewhere and start figuring out what it is you want to see in your career, because the opportunity to take on those skills and leverage them within the field is the time. Like this is the time to learn these skills and start going off.
Yeah, and Sandeep, as a founder, how do you see, because you're not dealing necessarily with computational designers internally, I assume. Correct me if I'm wrong. How do you see with the goals that you're trying to achieve, why don't you have a computational designer versus a software developer?
We actually do. So on our research product team, we have a few computational designers. And of course, that's separate from the software team, because like Brandon correctly pointed out, not a lot of software developers are trained to even think in 3D or even think what happens when buildings are coming together. And there's definitely kind of a layer of language and translation, and also knowing what is possible and knowing what could be possible just helps us make reasonable, reasonable choices versus go down a rabbit hole that just doesn't even make sense and keep pursuing it. Like we're at no point pursuing, and this is a common thing that comes up anytime technology or computational design is being discussed, invariably, oh, are we automating the role of the architect? We're really not. That's not the rabbit hole that that from everybody's presentation seemed like truly anybody was going for, because that is a rabbit hole. Like there's just so many variables to balance. That's just not possible. There's just so much art and creativity that goes into it, but it is possible to understand, okay, what are like all the boring tasks? Like originally, I remember version 1 of cove.tool, when I was still sketching it on a piece of paper, it's like, this is going to be the TurboTax for performance modeling. I mean, it's not fun to do taxes. Everybody has to do taxes. Might as well do it in a simpler way than a non-simpler way. And that's kind of how we think about joining the two, just making our lives easier, just, taking care of the tedious tasks so that we can focus on the actual aesthetics, the actual design, the actual thinking about the big problems that software is not at par yet to start dealing with. There's plenty of things software is at par yet to dealing with. There's plenty that it isn't.
So speaking of that interaction between computational designers, developers, to kind of figure out what's possible, what could we do, what should we be doing? Brandon, what this is a question from someone in the audience. What is the dialogue between the design team and the dev team at KPF?
So no, that's a great question. So the translation between, these are understand like what design team's struggling with and synthesizing that into like, okay, is this an engineering problem? Is this an area that we actually need software development to solve? Or is this like a workflow problem that we can solve in other ways? So there's definitely that layered kind of questions you ask yourself when you're tackling a problem, because you can definitely over engineer a problem that was never an engineering problem to begin with. And I think over time, you just develop an intuition, like, okay, like this, we can solve this very quickly. As much as it pains me to say, we can solve this in Excel and we don't have to spend 50 hours trying to over-engineer a dashboard for this, right? So I think it's understanding, looking at these problems and seeing, are they software engineering problems or are they just workflow problems that can be solved in other means? Because I would say that when I've seen certain issues come up that are like, here's one. Every firm now who signed up for the AIAD 2030 challenge needs to report their energy modeling, right? So you're talking about like talking and communicating with hundreds, if not thousands. I mean, thousands would be crazy, but yeah, let's just say a lot of consultants. Every consultant you're working on a project with, that is something that, if we lived in a world where there was a software to report all that information automatically. But what I'm assuming is that most firms are going to have to try to manage that themselves, right? Either having design teams report that information, talk with their consultant, get the energy modeling in. Some of the projects that you have in-house, you're modeling for, and you have to report that information. So it's like you have a complex like network of information that you need to report, standardize, and the most important part, it's not just about reporting, right? It's about understanding and learning from, which we have to get to once we get past some of these administrative tasks. And that's an example of one of those things that is a software development problem. We can develop a software to allow the consultants, in-house designers, and design teams all collaborate around just reporting, so we can actually get to the good conversations about energy modeling over time through the life cycle of a project. So I would say, like, hopefully that answers that question.
Yeah. So general question, are you seeing recent graduates having a better grasp on computational design as they come out of school, or do you seem to be helping new hires learn, since you cannot always teach old dogs new tricks? I'm an old dog. That's from somebody in the audience.
Yeah, I was gonna say you got to put like an age category for old dog versus new. Although like just, I mean, yeah, I mean recent graduates, that is definitely. I don't think the grasshopper was part of the program that I went to when I went to architecture school. That wasn't a thing. I was doing something cutting edge that people were just now starting to wonder if it was even possible. So definitely new tricks being learned by not recent graduates. So they definitely know that. But I also think that it, the more tools that keep coming out, they are making that connection easier between, continuing with the analogy, old dog and new dog, just because I mean it's the old dogs that are selling the projects. They're the ones going to pursuits. They're the ones winning it. So no matter how much fancy stuff the person right out of school can do, if the person pitching it to the owners can't showcase the value, can't understand the value, or can't showcase the value, it becomes really hard to make the sell.
Yeah, you can
Oh,
go.
I was going to say, I couldn't agree more, is that the communication of this information is so crucial. Like a large part of that project I did around hurricanes, we were visualizing a database, a very rich database that had been sitting around for years. And we're just like, the engineers like, we don't know what to do with this, but we know it's cool. It's like, okay, like what kind of decision are you trying to understand? So to answer that, to kind of get around that, I've seen a lot of students come out with like surprisingly machine learning. A lot of people are chasing down, for some reason, GAN is very popular within architecture. I'm not necessarily sure why, but it is. I guess it's for like procedural generation for like plans or geometries. So I've seen a lot of machine learning and Python. The thing that's a little bit difficult, and maybe this will change in the coming years, is that, let's say you want to develop something in Rhino, Rhino Common. You're probably more suited to do that in C#, like within the Rhino interface, or a grasshopper script. Now, the speed differences are, you can argue all day about the differences between C# and Python nowadays, or C++. But I'm curious to see like these new languages that are coming out and becoming much more fluid and much more intuitive. Because when I first learned C#, it was not intuitive at all compared to like JavaScript or Python. And so I'm seeing a lot about Python, machine learning, and much like Grasshopper is kind of like almost common now, where I'm seeing like Grasshopper across the board for a lot of candidates, and then seeing like Python and some C# coming out, and machine learning.
Dongyeop, how do you deal with maintenance when it comes to your tools, relative to especially dealing with like tons and tons of projects? How do you how do you get feedback on those tools, and how do you get feedback in terms of continuous improvement, and how frequent do you update?
Yeah, I think that's a very good question. It's maintaining that clusters are it's not easy. Like I even though I package them and I try to clean them a lot, I didn't really document them. So it's later when you open that, it takes time to understand the logic again. So that's one of reasons why we try to refine them in C#. It's much easier to manage and update the versions of that component. So it's a constant battle, like how we can manage that. And in terms of user feedback, honestly, it's not a lot. Like when people ask for something, I send them examples, and then they use something and they kind of want to, they find some bug, and I can fix it. And the main source that I'm refining those the clusters are, I'm also I'm part-time technology group, and also part-time architects working on projects. So I constantly use them. So I'm both a developer and users. So that's a good way to refining them. But unless we open them up to the general public, it's hard to get user feedbacks. So that's the one issue we are trying to approach, to discuss in our company. But at the moment, that's how we manage them.
Yeah. Brandon and Sandeep, you guys are dealing with, I would say, more different tech stack, right? So how do you deal with maintenance, and is there anything we can learn from? And when I say we, I mean like the broader industry that's leveraging Dynamo, Grasshopper, visual scripting. What can we learn from you guys who have gone deep into developing code and things like that?
Yeah, for sure. I feel like no matter what I say here, my CTO would be like, "No, you said it wrong." So I'll take a crack, and hopefully he won't ever see this video, so I won't have to deal what he thinks about what I think he does. So I think the key items that I think really help us make sure that our entire tech stack is really, really stable is, of course, we have multiple environments. Of course, just it's a whole other range of challenge when there's like 10,000 active users to make sure that it's scalable, because whatever worked at 100,000, gosh, even 5,000 doesn't work at 10,000, and will definitely not work for 50,000. So I think just making sure that we're developing it with scalabilities. We do tons of automated testing. It's kind of like, I guess it's similar to, like the boring task in architecture. Like, I don't know, like when I was an architect, we always told the interns, you'll draw toilet plans for 2 years until you're trained. So I guess like building automated testing is equivalent maybe to that, just because it's not glorious. It's just automated testing to make sure things don't break. So I think we just have a lot of automated testing and, dedicated QA team and like dedicated in-house testers who are architects and computational designers and have many, many thoughts and opinions about everything, which is awesome, which is exactly what we need. So we test it with our user base, and then we'll launch it with our small core group of users. So don't launch it to all 10,000 people at once and say good luck. We'll launch it to a small suite of users that have said to us that they want to be always on the cutting edge of everything that's coming out, so they can test and provide feedback so we can incorporate what they're thinking into the next version of the app. And then once it kind of goes through that process, we'll make those changes and then launch it to the whole wide world.
The one great thing that comes out for like when you take code out, or like what you're trying to solve within, let's say Grasshopper compared to like C# or Python, whatever solution you're using, you can't diff a Python or a Grasshopper script, which is unfortunate. You can't track changes specifically. One of the greatest inventions within the coding paradigm is the invention of Git to track per line changes. But I would say one thing I definitely learned from my previous experience as a software developer on a team is that we would have dedicated time to documentation and unit testing. So much to what was spoken to earlier is that you don't just spend time and document or plan time to create a solution. You also add a chunk of time to document and unit test to make sure it works before you integrate it into a larger platform. And then what ends up happening is when you push your code to a deploy server, it has to pass all the tests before it can even get past to the next phase. Now, on the Grasshopper side, especially thinking through, like, I haven't really seen architects spend that time after they complete a process or a workflow to document and understand what they did for future people to look at. I know in Grasshopper, like the note taking or the scribbles are a little bit, I mean, they're very different than like code comments or unit testing. But I would say regardless of whether you're doing it in code or Grasshopper, spend that time to think through document what you have. And then another concept to think about is like test-driven development. So you actually write your test first before you even develop what you're going to create. So it's like you doing the outline of what you're going to create and say, all right, it's going to input these, it's going to output this. And then when you create it, you see, oh, well, it passed all the tests and I'm going to run it through the actual test. And then the redundancy test is when you basically bombard whatever you made with as much weird inputs as you can possibly think of, which is some of the creative components of coding. Is that this thing expects an integer or a float. I'm going to throw an HTML document at it because someone sometime might try to inject like an HTML document. So there's a lot of creativity and robustness in the testing paradigm within development. But I would say like planning time to document what you create after you create it, but which I guess comes after the test-driven development that you do beforehand.
Yeah.
I just have to add that was so true. Can never underestimate the creativity of users at uploading things to a platform.
And with test-driven approaches, I mean, that's where the automation benefit comes in when you're able to write these unit tests and kind of just run them through. But we don't necessarily have that luxury using Grasshopper. Shifting gears a bit to Sandeep, you mentioned something about having a technical CTO, essentially. And for firms that are beginning to see where the industry is going, because we have this paradigm of, startups emerging out of an understanding of we create value across our value chain, and different people are beginning to see these opportunities and honing and develop, a startup that kind of provides that value exponentially, right? So firms are starting to see that. What kind of advice will you have for firm leaders that are trying to dabble into, you know, expanding, expanding how they deliver services? Um, yeah, any thoughts on that?
Yeah, for sure. I mean, high level, I think it's just really helpful to know what and why. I think if there's a very, very clear answer to both of those, I think it's a fantastic idea. I mean, I definitely believe that firms leverage technology, but having in-house expertise to take that technology to the next level, or in-house custom workflows to really, kind of showcase their unique style. I think that's absolutely fantastic. As we continue to develop, like back in the day, different design firms had their, unique way of drawing the trees or unique way of physically drawing the floor plans, right? So it's not quite the same, but truly every firm having their unique print on how they do stuff, I think is truly powerful. But just having a very focused scope or very clear understanding of what the scope like, and it's okay if it's not clear at first and there's a period of exploration and then realizing what the scope ought to be, I think is critical, just because creating technology without a extremely clear scope, if there's a return on investment that goes along with it, if that's part of the firm value, maybe the return on investment is just part of more projects being won. I don't know how the math of each firm works, but just I think scope and return on investment, that's how we think about everything.
Speaking of return on investment, someone asked, for completed scripts and tools, do you find that there is a diminishing return in how robust a tool becomes in comparison to how easy it is for someone to use? At what point do you decide a tool needs to be broken up into smaller modules or functions? For instance, Rhino and Revit are ridiculously robust tools, but have a demanding learning curve. That's very true. Many of the most successful scripts have been extremely simple or are intended to solve a single thing that more robust tools don't do. So for Cove tool, is there a point that you add so many features that it detracts from ease of use or becomes too complex for those entry level users?
Yeah, I can definitely answer from the Cove tool standpoint, and would kind of love to also hear, um, like especially for Dongyeop, like the however many modules you had. I thought it was cool, but I was also a little bit scared. Would love to kind of hear your thoughts on it as well. I think from a Cove tool standpoint, I do think that there's a point in time where there are diminishing returns with static scripts. However, with the power that we have of web interfaces, developments for, I mean, React, or really just there is a way for the platform to configure itself based on who's using it. For example, we have different versions of the software, right? There's the architect mode, the engineering mode, the contractor mode, and the developer mode. So, I mean, the architect doesn't need to know all the nitty-gritties of the fan speed, or exactly what kind of a heat recovery system with what integrated part load is going in. And the mechanical engineer a lot of times doesn't need to know about what the view quality is like from the second floor desk looking out. And I think just being able to build in that intelligence, which it is possible to build in, um, it is easy to keep tools to still be easy. Our goal when we started Cove Tool, and it's true so far today, is that the 20-year-old and the 70-year-old should both be able to use it. So that's the goal that we're after. That's the goal that I've seen be true so far, and that's gonna stay the vision of the platform as we continue to add more stuff to it.
Don't did you because I think Sandeep was interested in your own take on that.
Yeah, I think it's just scary to have see the all those clusters, the number of clusters growing, and it's hard to manage them. I admit them, but it's the part of them are clusters, and part of them are tools, and it's not just created by me. It's the collective effort to have this library, and I see them as and I find that the simplest tool is used most, like with dynamo graph, do very simple efficiency thing for documentation, just detail numbers and things like that. That kind of scripts are used the most, and the complexity grows, then the number of users may kind of tend to decrease, I find, because you also have to learn how the tool works, and so that takes time. The what I see from for what I see our clusters as more like it's a tool, but they are also kind of a learning thing. So when people, they can open it. We don't have any password on it, and they just open it and see how it goes, and they just do whatever they want. They customize it, and they can just export it, and they do something else. It's totally for people to play with it and learn from it. And but the direction we are going to update these kind of the package the clusters as are through Rhino Common and C#, and it's a proper tool to version control, and it's much easier to read the logic, and it's much easier to test the components. So I see, like if I see something that needs to be refined, I'm planning to develop in C# rather than the updating that clusters, and those clusters are really our library to learn and explore the different things to to reduce the scripting times and get it work quickly.
Thank you. Maybe we should shake some tables a little bit. Um, do you think the industry is ready for software developers? All right, let's hear it.
I think so. And again, I'll go back to my experience, like being in New York City and seeing the community so small for an industry that has so much potential. It just feels like it's like there's something's gonna give. Like we're seeing all these startups, and I'll take I guess the now collapsed WeWork. Right, they were starting to try to create a value proposition that infringed on the architectural practice value proposition, right, on the real estate development side. We're seeing now more than ever is that the value proposition architects are making to clients is drastically changing and being competed for by technology firms, by technology first firms who are now hiring architects, hiring computational specialists to come in, and then their market who they're competing with has now just expanded. So when the question comes to like, is now the time for architecture firms to be hiring software engineers? It's like, if you don't do it now, you might be left in the dust. Not only for adaptation of new technologies as they're coming forward to stay competitive, but also as the analytic tools become much more robust, to be able to adapt those and use those within your practice and understand the inputs and customize them to your needs. It seems like it really does feel like now is the time to bring in that capability and grow it, and especially growing that in-house expertise and those connections early, rather than trying to scramble to try to get a capability later down the line.
Yeah. To add on that, maybe don't give Sandeep, you can answer this as well. I know I said software developers, but even computational design integration, not just in the design but in the business. Do you think the business model supports the integration of proper integration of computational design and a software developer in practice?
I can take a quick pass at that. Curious how, and I'm sure the math that we do will be different to the math that an architectural firm would do. So I'm very curious on those thoughts as well. But I mean, 100%. I mean, just even truly return on investment, 2/3 of the industry, and this was part of the AIA report a couple of years ago, gets paid in lump sum. So if we're making money in lump sum, any efficiency that we make in our workflows by not having to do the same thing again and again, part of when I showed kind of my intro, I showed the urban context automatically being loaded. I can guarantee you there's people on this call today that, similar to myself, have spent time outlining context buildings, counting number of floors on Google Earth, and extruding it. That's 8 hours of some person's time. That was 8 hours of my time, billed at the time at what, 150 or whatever. I think I think it's definitely worth it. It's worth it to spend on that, because return on investment is high. Because yeah, sure, we bill by the hour, but the contracts are negotiated lump sum for 2/3 of us.
Yeah, I think adding to the Brandon and Sandeep's the comments, I think our interest is ready to take software engineers in our the company. I think but we also have difficult challenges because we all know the architecture companies' revenues are not matching IT companies' revenues, and it's all like a balancing act. We want to hire software engineers, but to have enough budget and can he generate enough revenues to the balance acts on strategies. We are talking about we are talking a lot about saving time using these tools and talk about return on investment. We say, but from my experience, not just in our company, but from my companies, the designers tend to spend all the times. Like if you save time, designers tend to explore more designs until we run out of budget because we care about the design qualities a lot. That's the kind of the industry we as a whole. We don't have I can say the smart ways to strategize our managing our time to produce something, because we are not like automobile manufacturers. We are, again, we are not like a mass production companies. All those mass production companies, they standardize they lean their manufacturing process to save cost and things like that. We don't have that kind of rigorous the efforts to manage cost and time and things like that. So I think it's challenge. We all know it's time to have this expertise in house, but I think we just have this huge challenge how to balance our the strategies.
And there's we've touched around software developer. There's a range of, like, you're dealing with UI UX, you're dealing with, like, if your thing is on the uh a web-based thing, you're dealing with like reliability engineers, you're dealing with back end, front end. Where does an architecture firm or an engineering firm start from when they're thinking of hiring um you know a software developer?
I can take one pass. I'm super curious to hear Sandeep and Dongyeop on this point. Is that there's as discussed, there's a lot of like low hanging fruit of tasks that we don't, like, architectural designers shouldn't be tackling every single day or starting from square one on every single project, and especially discussing around that idea of, and I'm speaking speculative on my own opinion on this one, is that I think it would be better for the designers to have more time to go through design iterations, removing those barriers that they get, hopefully not too lost going down the design iteration route, rather than being bogged down by whatever technology or barriers are in their way from doing those design iterations quickly and going down those pathways. And so, like, things like automating certain exporting. Now we have Rhino inside now, which allows a lot of exporting of geometries into Revit. But even thinking before we had that, a lot of design firms probably had some kind of plugin to export data from Rhino into Revit, and into some capacity and various capacities, right? And so I think even like looking at tasks within the in minute workflows, you can probably find patterns that every designer is doing on every single project, and just try to, if you can clear that out, you save X amount of hours across an entire design team for the future of the firm. And of course, you might have to refine that tool or workflow over time, but I would say it's worth the upfront investment to automate that now, so you can have those conversations later about, okay, like how do we improve this tool a year down the line now that we started from here.
Sandeep, Dongyeop, he was curious to hear your take on it. I'm curious too.
I agree. I mean, I really just agree. I mean, having more iterations or just refining it further. And I mean, I what I'm a corrupted architect because I don't practice anymore. And you know, like sure, you're right. It's like Don Yip when you said like, you know, if designers have more time, they'll just design more. Like I understand that. I've seen that. I've experienced it. Um, but I think we can lay out the math differently, right? Like if the timesheet doesn't say 10 hours, it says 6 because that's how we did the math because we incorporated the cost of the software development. I'm sure we'll figure out a way. But I do believe that there's a way to iterate over and get value from what we've already done. Like when I worked at a large architectural firm, we still had to talk to actual people that had done a particular hospital design to understand their takeaways from it. Why wasn't it all in one searchable database? Why weren't we learning from ourselves? Why were we trying to reinvent the wheel every single time? I mean, to their credit, plenty was automated, but plenty wasn't. So I think that's definitely a great place to get started.
Um, Dongyeop, here's a question. I think actually it's for everyone. What kind of metrics do you use or put in place to measure ROI on, you know, computation investments or software development investments? How do you measure that?
Yeah, we the track the use of tools. The all the tools we put. We have tracking. The tool for any tools we are developing. I think Richard Schmidt is in this meeting, and he's developing. He developed those things to track all the uses. With this COVID situation, we need to update that the data, but we lost a way to track those use. But that's how we mainly use, and we update them in real time in Microsoft Teams, connecting a Power BI. So we have a way to track all the uses. We don't track the use of all these small clusters, but we do track all the dynamo graphs and grasshopper tools.
So do you track them, compare the usage per project, comparing them to the amount of time or cost that went into developing them in order to say, yeah, this was the right decision to make?
Yeah.
Did over time. Yeah.
Yeah. Over time, we don't exactly know how many hours to save, but we have an estimate of the saving hours for the specific tool, right? So we can guesstimate if that's used 100 times, 100 times if that tool saves 1 hour average, then we can kind of quantify that ROI. But other than that, I think that's the main kind of the way to get the guesstimate the ROI on that development.
Okay. Brandon, you were gonna say something.
Oh, I was gonna say that there is one metric that we use in house. Was we have a team of computational designers who get deployed onto given projects to help out those design teams, essentially create those design spaces and do performance analysis across the design. And one metric that we've done is for the software engineering impact is by creating the smart tools, by using software engineering to develop tools for those computational designers, how many more projects are they able to work effectively on? So like, last year we worked on like around 30% of projects, which is still such a low number for the KPF UI team to work on, but there's so many projects and competitions that we're still making a fairly large chunk. But one metric that we've looked at is how do we increase the capacity without increasing the amount of hours spent for each designer, right? So we're essentially extending their capability to work on more projects while staying mentally agile to that process. So, if we have 3 or 4 different environmental specialists throughout the year, how many more projects can we help them work on and make an impact on effectively by deploying tools for them to work on more projects?
Speaking of agile, how do your teams stay agile? Software development teams, computational development teams, how do you what kind of methodologies? I know there's, different things, Scrum, Kanban for software development teams. Well, how does that even translate into practice? Any thoughts on that?
Yeah, for sure. I mean, we do use a agile framework, and we do use short weekly sprints, which is shorter as compared to most, where we're able to track things on a much closer basis and be able to switch gears as needed on a pretty rapid base. So I think the weekly sprints definitely allows us to accomplish that, and just being, tightly knitted, like clear workflow between QA versus like anytime, like, things are getting constantly deployed. So we don't have like a special day or time or, whatever, when things are getting deployed on our internal servers, like things are literally deployed multiple times a day, so that, they're constantly getting tested, constantly getting updated. So that definitely helps.
For the audience who might not know what sprints are, do you want to quickly describe what that is?
Definitely.
Yes.
So sprint is basically like project planning, the amount of stuff we want to accomplish in a given week. So we'll pull in, like, whether it's whether it's a bug fix, whether it's a brand new feature, whether it's an update to an existing feature, we'll pull in those tasks because we have a large list of stuff that we constantly want to do. So we'll pull in a particular group of tasks for that particular week, and that's a sprint.
There we go. Essentially, like the amount of work stays the same for that period. So thanks for that. Yeah, Brandon, did you want to answer?
Sure. One piece, definitely doing the sprint schedule. It allows you to measure over time how effective you are at tackling different challenges. So, you can look at one of the great pieces of software development, which is I think a little bit more difficult to adapt to architecture, is that software development has very discrete tasks. So when we talk about like, this is a bug, fix this bug, move on to the next, move on, create this feature that does this slider. So they're much more discrete tasks, and a lot of that is built into the agile workflow for like a project manager or whoever manages that, gives out those tasks. The developers see it for the week and then tackle that. And if they have extra time in the week, they try to take on another task. In architecture, it feels that those tasks aren't necessarily completely clear or concise enough to describe in that weekly plan, that it becomes a little bit difficult to track them over time. Another piece that we found really useful is project burn downs. And essentially what those are is at the end of you can do it at the end of a sprint. So after you finish a series of features or a series of developments within software, and I mean, honestly, I think architects should be doing this more, is that you spend time at the end to talk about what went right, what can we do better, and what potentially went wrong that we want to recognize and share. And a large piece of that is that you might hear individuals from across the table or around that round table to say, oh, I really struggled with this. It's like, oh, like we can potentially work with that on the next time we do this kind of challenge. So it's sharing, much more sharing knowledge that is somewhat difficult in a larger firm when you're moving like from project to project very quickly, that the time isn't taken to say what we learned and sharing the knowledge with others, just to have that more so candid discussion.
Dongyeop, do you implement anything? Like, I know it's hard for computational, like dealing with this in practice. But what do you use to stay agile?
Yeah, I mean, we also, I mean, I'm not a full-time developer, but we when I develop Rhino Common, the plugin, then we use the Sprint as well. I don't use as much as Brandon or Sandeep, but we are required to do that. But to develop these grasshopper clusters, we many times we we are using project hours, and project hour, project the typically fast paced and very rushed, and we we need to really try hard to package them. I as a technology group, as a member of technology group, technology practice group, I have a kind of tendency to be as early as possible to package them, so that I do my job. But as a whole company, I don't think people are doing it. But that's I just do my best to make them available for everyone, and upload them to our the SharePoint site that will replicate it to everyone's computer. Yeah, so that's what I do typically.
Fantastic. Well, this has been very informative. Thank you guys. A final question is, what books are you reading? What books do you recommend?
There's none that I'm reading that I would honestly recommend to this audience. So as a founder of a startup, you're constantly learning brand new things. So right now, I'm not deep into product or software at all. I'm really, really deep into marketing and sales. So if any of you is interested in marketing and sales books, I can, for B2B SaaS platforms, I can recommend one. But I don't think it'll be fruitful for this audience.
We have some business owners on the call, so it might be helpful. But,
Yeah, there's one that I like. It's called Never Split the Difference.
okay, so guys, check it out. Brandon, Dongyeop.
One book that I read years ago that I've read a couple times, and it's not necessarily related to software engineering, but I guess maybe tangentially, it's Creativity Inc. by Ed Catmull, the CEO and founder of Pixar. A lot of the methodologies that we've discussed here were discussed in that book, and that book is primarily about cultivating a creative culture within your office. For some reason, that book really inspired me. When at my previous employment, I was a third hire of a startup, so we were doing that fast-paced movement, and that book really inspired me to continue pursuing this architectural and technology-focused area.
Nice.
Yeah, I don't have the kind of the fundamental books that I can think of right now, but I usually like the books with the kind of that gives me the inspiration for computational design, like whether it's the origami folding technology. And I recently someone recommended me to buy Geometric Computation. It's called Foundations for Design by Joy Cole, and I heard that it's a great book that has that I can utilize the coding for the geometric computation. So I find the books that are kind of related to my work, and then I get the inspiration from.
Thank you very much, panelists. Thank you so much for honoring our invitation to our spring event. And this wraps up the event for today. Please join our Discord channel. You would see more of that information on YouTube when you watch this recording. And I think Leland mentioned it earlier on. For the Detroit members, join so that you can be more involved in elevating the conversation in our area and just even being exposed to things that are happening outside. Um, Again, we want to say thank you to our panelists and have a good night, everyone.
Thank you very much.
Thank you.
Bye, everyone.